Hello, good evening, everyone. Welcome to week four of Fuzzy Sets Logic and Systems and Applications. I am your TA. My name is Pravalika, and I'm a PhD student and a Prime Minister Research Fellow from the Indian Institute of Science. Just give me a minute so that I'll just share my screen. Screen is visible. Just put it in. Yes. Okay, all right. So, a couple of instructions as usual before we begin. So, this session is being recorded and the recording will be posted online. Okay, so it will be posted on YouTube and the link will be given in the NPTEL portal itself. Right. And please be respectful during the session and please put all your questions in the chat box during the session. So, in the session, I'll be covering only a little bit of theory, like not too deep theory, a little bit of theories, which will help you in solving your problems and all of that. Okay. And in case wherever needed, I'll also help you with MATLAB. Okay. And after 12 weeks, I'll also take one additional class. So in case if you want me to like repeat some topic that you want right before your exams or something, that will be really useful for you. Okay. So let's just see what we have covered last week. And after that, we'll come. So last week, we were looking at different properties of fuzzy sets, right? So we have seen how to take union of two fuzzy sets, right? So for a union, you basically take the highest or the maximum membership value for a given x value, right? So we have seen union, then we have seen intersection. So in intersection, we take the minimum membership value for a given x value. And then we have seen the difference. We have calculated how to take the difference for A given B and B given A, right? And then we have seen various other properties and the properties which fuzzy sets do not follow. So please remember what all properties that a fuzzy set never follows. Okay, which includes law of contradiction, law of exclusion, excluded middle, absorption of complement, right? And we have seen other properties such as commutativity, associativity, idempotency, involution, absorption, De Morgan's laws, right? So all the other properties that a fuzzy set follow, similar to a classical set. Oh, I haven't. Okay, I'm so sorry. I'll check today and I'll post today's class and last week's class. Okay, I'm sorry for that. Okay, so we have covered all of those properties, right? So for today, we'll be discussing about distances. So we why do we calculate these distances, distance between two fuzzy sets? It is basically to know how similar A and B, that is two fuzzy sets, are. Okay. So for today, we'll be looking at this. So given A and B are fuzzy sets, and P of A comma B is the distance between the fuzzy set A and B. Okay, and how is it calculated? So today's class won't be that long. We'll be covering only about distances today, so it won't take that long. Okay, so we'll see how to calculate the distance. We'll kind of go through. We'll take some examples and then we'll calculate everything. Okay, sounds good. Okay. So for the distance, for a discrete discrete values, so we use summation, whereas for a continuous one, we use an integration, right? So new d a comma b. Here, this is a membership function, membership value, right? So the even for the distance, when you're calculating distance between two fuzzy sets, it is also going to give you a fuzzy set. Okay, so we will see how it is going to give us. So first we will calculate the membership value for a given X value. Okay, how do we get that X value? We will look at it later. Okay, so what you do is first you take the membership function with respect to X, with respect to A, and one membership function value with respect to B. So here you have to note that the X values of A and B are not necessarily going to be equal. Okay, you take the membership values and then you take the minimum value of those two, right? So then you will get some value, and similarly you will do it for different value. Okay, we'll do it with an example. Okay, this is there is no easy way to put all of this in terms of words. So we will see how to calculate this a little later. Okay. Yeah, as I said, the distance of A comma B is going to be another fuzzy set. Okay. And in this whole thing, the one main parameter is called delta. So delta is the difference between corresponding generic values for a generic variable. Okay. So the generic variable is nothing but X. Okay. So what you do is you take the differences between all X values. So for example, so here I have A and B. So I have 1, 2, 3, x equal to 1, 2, and 3 in A, and in B, I have 2, 3, and 4. Right? So let us calculate. We'll take the absolute difference of x values. So let us just call this one as, just change the color. This one as x1, x2, and this is x3, y1, y2, y3. Okay, let us take the differences. Let's do x1 minus y1, x1 minus y2, x1 minus y3. Okay, what are the values? 1 minus 2, 1 minus 3, 1 minus 4. Right? So that is equal to 1, 2, and 3. Okay, that is with respect to x1. Then again, we have to do for x2. x2 minus y1, x2 minus y2, and x2 minus y3. So what are these values going to be? 2 minus 1 is 0. 2 minus 3 is 1. Absolute difference. Okay, it's not normal difference. Okay, the distance is always a positive value, right? It is equal to 0 or greater than 0, right? So we are not going to take any negative values here. We are only taking the positive values. Okay, so x2 is 1. x2 minus y2 is 1. And then x2 is 3. Sorry, x2 is 2 minus y3 is 4. So that is equal to 2. Then x3 minus y1, x3 minus y2, and x3 minus y3. So that is equal to 3 minus 2 is 1, 3 minus 3 is 0, right? And 3 minus 4 is 1, right? We are taking the absolute values. So if I write all of this as a single set, it is going to be 0, 1, 2, and 3. That's it, right? So these are our delta values, all the possible delta values for given two fuzzy sets. Okay, so the first step in finding the distances between two fuzzy sets is essentially going to be to find delta. Okay, so now we have all the delta values. Let's write delta 0, 1, 2, and 3. Right. So now let us find how to calculate the distance. Okay. First, let us see for delta equal to 0. So delta is equal to 0 in two cases, right? So let us divide a table this way. So in this table, we have XA and XB. Okay, I'll tell you what XA and XB are and their corresponding membership values. And then the minimum of the membership values. Okay, here I'll erase this off and we'll come here later. Okay, so delta is 0 in only two cases, right? So when x value is equal to delta and like the value from a is so the x value from a is equal to 2 and the x value of b is also equal to 2. That is one case. Another case is 3 comma 3. So from a value, from a fuzzy set, the x value is equal to 3 and from b fuzzy set, the x value is equal to 3. So only then we are going to get 0 as a delta, right? 2 minus 2 is 0, 3 minus 3 is 0. So these are the pairs we have. Okay. So xa and xb are going to be 2 comma 2. Okay. So with respect to fuzzy set A, the membership value of 2 is 1.0. Okay, let us write it. With respect to fuzzy set B, and for x equal to 2, the membership value is 0.4. Right? Clear so far? Okay, we will leave it for here now. Let us go for the second case. Okay, now the case is 3 comma 3. Okay, so for given fuzzy set A and for x equal to 3, the membership function value is 0.3. We'll write it. And for fuzzy set B, for x equal to 3, the fuzzy set is 0.4. So it is 0.4. Now we have to take the minimum value in between that both the membership values that we have. So in between 1 and 0.4, the minimum value is 0.4, right? So we'll write it as 0.4. So in between 0.3 and 0.4, the minimum is 0.3. So now I'll write it. So now I want to get the membership value of the final for delta equal to 0. I want the membership value. So it is going to be 1 among these two. So which one are we going to take? Now we are going to take the maximum value. So the maximum value for this is 0.4, right? 0.4. So how do you write this? The membership value by the delta value. So for x equal to 0, the membership value is 0.4. Similarly, let's try and do for delta equal to 1. So what are the cases that we have for delta equal to 1? Right? Okay, if we have 1, 2, 3 and 2, 3, 4. Let's write 1, 2, 3 and 2, 3, 4. So for delta equal to 1, what are the pairs that we can form? I can take 1 and 2 here, right? Okay, that is one case. Another case is going to be 2 and 3. 2 and 3, right? And the other case is going to be 3 and 2. 2. Any other cases? We can also write 4 and, 3 and 4. Since we are taking absolute differences, it is fine. Even if we take it as like 3 minus 4 is equal to 1. Even if we write that, it is fine because we are taking absolute difference, right? Are the 4 cases done? Fine, or is there any other case that I have missed? Okay. In case if I missed any case, please let me know. Okay. So as usual, we'll divide the table. Since we have 4 cases now, we have to be a bit more careful and we'll divide the whole thing into 4. Right. Here we are done. So let's write the XA and XB values 1, 2, 2, 3, 3, 2, and 3, 4. Right? Okay. So from fuzzy set A, we'll write the membership values. So for x equal to 1 in fuzzy set A, the membership value is 0.5. For x equal to 2 in fuzzy set B, the membership value is 0.4. Next, for x equal to 2 in fuzzy set A, the membership value is 1.0. For x equal to 3 in membership B is 0.4. For x equal to 3 in fuzzy set A, it is 0.3, right here as well. Right? For x equal to 2 in fuzzy set B is 0.4. And x equal to 4 in fuzzy set B, the value is 1.0. Right. So now our table is finished. Half finished. So now we'll go for the minimum values. So the minimum in between 0.5 and 0.4 is 0.4. The minimum in between 1 and 0.4 is 0.4. The minimum value in between 0.3 and 0.4 is 0.3. The minimum value in between 0.3 and 1.0 is 0.3. So now for the last one, we take the maximum of all of these values, right? So the maximum value is 0.4. So now we'll write this as 0.4 given x equal to 1, right? Okay, so we still have two more delta values to find out. So you can find out for delta equal to 2 and for delta equal to 3 as well, right? Do you guys want to do? I'll give you some time. Okay, for delta equal to 2, please do this and let me know what is the result that you're getting. Okay, what is the membership value you're getting? And okay, for delta equal to, let's write the cases. We have 1, 2, 3 and 2, 3, 4. So we have 1, comma 3, 2, comma 4. That's it. 1, 3, 2, 4. That's it. Right? We have only two cases for delta equal to 2. So please try it out. And for delta equal to 3, we have 1, comma 4. That's it. If needed, I'll bring these as well. Okay, please try it out. I'll give you some time till 6:25. I'll wait till 6:25. And once you're done, okay. I have put the set A and B here on the right side. These are set A and B. Okay. Thanks, Yamuna. We'll check it out. Okay, in 5 minutes. We'll just wait for 6 till 6:25 for any more answers. Okay, if there once it's 6:25, I'll start doing it again. Okay. Okay then. Um, we'll do it. Okay. So we have two sets, right? Oh, I don't have to draw these. Sorry. Just give me 1 second. I actually drew more. Okay. So for delta equal to 2, we have 1, 3, 2, and 4, right? We have two sets. So for 1, so for x equal to 1 from from fuzzy set A, the membership value is 0.5. For x equal to 3 in fuzzy set B is 0.4. For x equal to 2 in fuzzy set A is 1.0. And for for x equal to 4 in fuzzy set B is 1.0, right? So the minimum in between 0.4 and 0.5 is 0.4, and the minimum in between 1.0 and 1.0 is 1.0. So the maximum we'll take is 1.0. So this is 1.0 given x equal to 2. Okay, fine. Then for this one, we have only one set, 1 and 4, right? For x equal to 1 from fuzzy set A is 0.5. X equal to 4 from fuzzy set B is 1.0. The minimum of these two is 0.5. And since we have only one, we are just going to be with 1. So this is 0.5 by 3. So the entire fuzzy set is nothing but 0.4 for x equal to 0 plus this one 0.4 for x equal to 1 plus 1.0 for x equal to 2 plus 0.5 for x equal to 3. So this is how we find the distance. And Yamuna, you are absolutely right. Thank you for your answer. Okay, so we have covered till there. Just give me 1 second. I'll finish off all the theory part for today. Okay, and at the end, if you're interested, we can do a couple more questions. Okay, sounds good? 1 second, please. Please explain the starting of the class. No, starting, it's actually the same. Okay, I'll give you a recap. Is that okay? So, in order to, yeah, got it. Why do we find distances between two fuzzy sets? It's basically to understand how similar are two given fuzzy sets. And when you find the distance between two fuzzy set, it also results in a fuzzy set. Okay, so that is essentially what I have explained in the first 5 minutes. Okay, and then we have seen what delta is. So delta is all the possible absolute differences that we can take for a given generic variable, that is x in our case. All right, so that's it. So I have given an example. I have taken two fuzzy sets and then we have calculated delta values for it. Okay, after that, everything continued. Okay, is it clear? That was essentially the first 5 minutes, nothing much more. Okay. So from here, we'll be starting arithmetic operations on fuzzy numbers. So when I say fuzzy numbers, it is complete. It's only a part of a fuzzy set. Okay. So here in this graph, if you look at, we we let us you can take any membership function graph. You can take a triangular one. You can take anything. Okay, but a fuzzy number is a fuzzy set that holds the conditions that it is it's a normality and its convexity. So if I am taking this, there is only one peak that I can find, right? That is at this point. At this point. So that is the only peak where the fuzzy set has highest membership value. And that is at a given x value. And in this example that I have shown here, it is 7. So the fuzzy number is equal to 7. Okay. But there are the singletons that we have discussed maybe in week 2 class. Okay. Where there is only one x value and a corresponding membership value for that x. So that is called as a singleton. And when it is there, then we term it as a crisp number. If we have multiple values and we are taking just one value, one highest p, it is called as a fuzzy number. Whereas if we have only one value that is also having the membership value equal to 1, then it is called as a crisp set. Okay, I hope you understand the difference in between the fuzzy number and this crisp number. Okay, so when we say arithmetic operations are all the basic operations that we basically teach for kids, right? Addition, subtraction, multiplication, and division. Okay. But since we are dealing with fuzzy numbers, it is not going to be as easy as those additions and subtractions, but it'll be quite different. Okay. So for today's class, we'll be only looking at additions. Okay. From the next class, we'll be looking at the other three arithmetic operations. Okay. So addition. So let us consider another fuzzy set C. That is where we are taking the addition of A and B. So how do the representation is similar to any other fuzzy set that we use, right? We have the membership value and then we have the corresponding X value, right? So C is nothing but A plus B. Okay, so now we'll write the membership value as nu of A plus B to find the membership value of this. Okay, so you're writing it as A plus B. So how do you find it? It's basically you take the membership values and you take the intersection. So what is intersection in normal terms? We take the minimum of the two given uh, membership values, right? So this is basically the minimum. And then we divide it by both the x values, we add and we divide it. Okay, we'll see how we can do that. Okay, here I have two fuzzy sets. Okay, so how do I write things? Okay. New A. Let's do one thing. Let's keep it simple. New again make a table similar to what we have done before. New B. Sorry, X A X B. New A. New B. And then the intersection. Okay, we'll do it till here for now. So previously you were calculating delta. Based on the delta, you are forming the pairs. But in this one, you're not going to do it that way. In this one, you are going to take each and every pair that is possible in between A and B. So first, let us take x equal to 1 from fuzzy set A. Fuzzy set B will take value 10. Then we'll take x equal to 1 from fuzzy set A and 11 from fuzzy set B. Again, 1 from fuzzy set A and 12, sorry, and 12 from fuzzy set B, right? And then 2, 2, 2, 10, 11, 12, right? Keep it longer. 3, 3, 3, and 10, 11, and 12. And then we have 4, 4, 4, then 10, 11, and 12. Space is not sufficient for us. Five, 5, 5, and then we have 10, 11, and 12, right? Okay. So for x equal to 1, from fuzzy set A, the membership value is 0.3. Let's fill it up. And for x equal to 2, it is 0.6. Right? For x equal to 3, it is 1. For x equal to 4, it is 0.7. For x equal to 5, it is 0.2. And what are these values? 0.5, 1.0, 0.5. Okay. I'm just writing whatever is there in the question only. Okay. It's nothing new. Everything is there in the question and I'm just filling up the table. Okay. Clear so far? In case if you're doing it along with me, I'll just give you 2 minutes. Okay. So that you can fill up everything. Okay. Okay. I hope you guys are done. Okay. So now we are going to take the intersection between nu A and nu B, right? Intersection means we are going to take the minimum value. So the minimum values in this, what is for the first pair that we have 0.3 and 0.5, we have the least value is 0.3. Let's just change the color. we have 0.3. Okay. Then for 1 and 11, we have the lowest value as 0.3. Okay. Then we have again 0.3. Then we have 0.5, 0.6, 0.5, 0.5, 1.0, 0.5. And then this is 0.5, 0.7, 0.5. This is 0.2, 0.2, and 0.2. Okay, so far we have completed this table. Now I'll add one more layer to it. So here it is XA plus XB. Okay, so we have taken the minimum values. So before in the previous when we were calculating the distance between two fuzzy sets, we were taking the difference between XA and XB, and we were taking that as a denominator side, right? So now what we are going to do is in place of difference, we are taking addition. Okay, so 1 plus 10, 11, 12, 13, again 12, 13, 14, is 13, 14, 15, 14, 15, 16, 15, 16, 17, right? So I'm just adding up all these numbers. Okay, is it clear so far? So now let us take 11s, all 11s. Let's go for a different color. 11. 11 is here. Any other 11s? None. Okay. So at one point side, okay, we have 11. And what is the corresponding value of 11? 0.3. We'll write 0.3 plus. Okay, 11 is done. So we'll just cut it off. Then let's take 12. How many times do we have 12? We have 12 here, we have 12 here. So for 12 values, we have two values. One is 0.3, one is 0.6. 0.3 and 0.6. Now what you have to do is similar to what we have done in distances. Again, we are going to pick the maximum value. So for x equal to 12, the maximum value for the membership membership values is 0.5, right? So 0.5 for 11, sorry, 12. So we'll strike that off. Okay. Okay. Now let's go and look at 13. So for 13, we have 0.3 and 0.6 and 0.5. What is the maximum value for it? It's 0.6, right? For x equal to 13, the membership value is 0.6. Okay, now 13 is also done. Let's strike off 13. Next, let's go for 14. So for 14, we have 0.5, 1.0, and then 0.5. That's it, right? 0.5, 1.0, and 0.5. So the highest value is 1. 0.1 for x equal to 14. Got it. Next, for x equal to 15, we have 0.5, 0.7, and 0.2. 0.5, 0.7, 0.2. Right? The highest value is 0.7. So 0.7 for x equal to 15. Okay. Now for 16, we have 0.5 and then 0. Sorry. 0.5, 0.2. Right? Highest value is 0.5. For 16. And then finally, we have one more left, that is 17, and we have only one value for it, 0.2 by 17. Okay, so this is addition of two fuzzy numbers. Is it clear so far? Okay. So far what we have done is A plus B, right? We have done A plus B. So you can try it yourself. Okay. You can also try B plus A. You you should be getting the same values. So A plus B is equal to B plus A. Okay. So are there any doubts so far? I have covered everything. Uh, I'll wait for 2 more minutes. If anyone has any doubts, I can just explain. Okay. So I hope there are no more questions. If in case if you have any questions, you are always free to drop the message in the chat box until 8 p.m. Okay. Okay. So let's look at some of the questions that were asked in previous years. Okay. Uh, so one such question is, what does delta represent? So what does delta represent in the context of computing the distance between two fuzzy sets A and B? Okay. So the context also will be given later in case if something else is also denoted by delta, then you should not confuse. Okay. So what does delta represent in terms of computing the distance between two fuzzy sets A and B? Please give your answers, whatever you think is right. Please give your answers in the chat box. Do you want any multiple choices to answer? If you need multiple choices, let me know. I'll read out. Okay. So, option A, the universe of discourse for fuzzy set A and B. First is universe of discourse. Okay. That is option A. Option B, the maximum membership value between fuzzy sets A and B. The maximum membership value between A and B, where A and B are two fuzzy sets. And option C, the difference between the corresponding generic variables of fuzzy sets A and B. Difference between corresponding generic variables A and B. So the generic okay, so the generic variables or values is nothing but x. We represent it as small x, right? When we are writing a fuzzy set. So we take the difference and that is our corresponding values. Okay. Uh, you are both right, Snehashish and Yamuna. Okay. So next question. For a given delta, how is the membership calculated? You can just say it in one sentence or I'll read it out. Okay. By averaging the membership values for all pairs with the same delta. Averaging membership values for all pairs. For all pairs with same delta. Option B, by taking the maximum of the membership values for all pairs with the same delta. Rest all the same. By summing the membership values for all pairs with the same delta. So which one do you think? Are we taking the average of the membership values? Are we taking the maximum membership values, or are we taking the summing? You are absolutely right, Yamuna. It is right. We are taking the maximum membership value for all pairs with the same delta. Amazing. Okay. So what conclusion is drawn from the distance between A and B and between B and A? So I'll give you the options. Distance are never equal. Distance are always equal. Cannot be calculated. Okay, please drop in your answers. So if you calculate the distance between A and B and between B and A, is it going to be same, or is it never going to be the same, or it cannot be calculated at all? Yes, Yamuna, you are right. So the distance are always equal, right? So it's just like even data points, right? Between point A and point B. From here to here, it is the same distance from here to here as well. From this point to this point, it is same as this point to this point, right? Similarly, even for the fuzzy sets also. Okay. Okay. What is the reason to find the distance between two fuzzy sets? Why do we find the distance between two fuzzy sets? I have told this in the beginning of the class. I'm not giving options for this. I'll wait for a minute. If nobody is answering, then I'll give the choice. Yes, Nehashish, you are right. So the reason why we find the distance between two fuzzy sets is basically to get the similarity between the fuzzy sets. To find similarity. Okay. So what is fuzzy number? Options. Discrete set with no variability. Singleton fuzzy set with infinite elements. A fuzzy set that satisfies normality and convexity conditions. Option D is none of the above. I'm not writing here. Okay. Any more answers? Snehashish and Yamuna, you are right. So it's basically a fuzzy set that follows two conditions. One is normality and one is convexity. Now only two more questions. So what is the difference between fuzzy number and a crisp number? Okay, it's too long to write. So I'll read. I'll read as slow as possible. So, okay. Option A, crisp numbers have infinite membership values, while fuzzy numbers have only one membership value. Okay. Crisp numbers have variability, while fuzzy numbers have fixed membership values. Option C, crisp numbers are singletons with only one membership value, while fuzzy numbers are sets with variable membership values. Yes, Yamuna, you're right. The option is C. So crisp numbers are basically singletons with one membership value, whereas fuzzy numbers are fuzzy sets with multiple membership values, but one value will always be equal to 1. Okay. Huh. Okay, this is like a summary, right? So, how are arithmetic operations, specifically addition, performed on fuzzy numbers? Okay, uh, I'll read it out again. By finding the minimum of corresponding membership values and then taking the maximum of the of the result. Okay, right. Minimum of corresponding values and then taking maximum of the result. Okay, option B is taking the maximum corresponding values and then taking minimum of the result. I'm not writing everything, right? By finding the sum of corresponding values, CV here is corresponding values. Okay. And by finding the product of corresponding values. So, which is the answer? Okay. Yamuna, any answer from you? Yes. So, Snehashish and Yamuna, you are right. Sindhu, we basically take the minimum corresponding values as we have seen here. So, basically, we are doing the intersection first. So, we are taking the intersection between both the membership values and then we take the maximum at the end. So, these are the corresponding values that these are the corresponding values. Okay. Then we get the result and then we take the maximum values. Okay. So, with that, we are done for this week's class. So, any questions from anybody over to this week's content? I'm so sorry I did not upload the last class one. I'll do it as soon as possible along with this class. Okay. Any more questions? Extension principle. Where is it? Let me just check. Is it part of fuzzy sets? Was in distance. Okay. Give me a minute. I'm just checking. Where is it? Can you please tell me which exact lecture it is in? Because I'm not finding it. 20. That's 17. Within the universe of discourse, X the distance between. Okay. So it basically means that, so from currently when you are calculating the distance between A and B, we are doing it in the universe of discourse X, capital X. Okay. So in case if you are going to change the universe of discourse to something else, let us say capital Y, then also the distance is going to be the same. Okay. Is it making any sense? Okay. Um, any more questions? But I know only the crisp of it, but Snehashish, I will go through a little bit more about that. And in next week's class, I will explain it. Okay, I'll explain it much better, and maybe if possible, I'll also take some examples. Is it okay? Okay, cool. So uh, that's it. So I'm done for this week's um, problem solving session. So thank you all for joining, and you guys are absolutely amazing for always answering and asking questions and all of that. So I really, really appreciate you taking your time for these problem solving sessions. So in case if you have any more questions, I'll be here till 8 p.m. Okay, I have to be here till 8 p.m. So I'll be there. In case if you have any questions, please don't hesitate to drop a message in the chat box. Okay, I will answer all the questions. Okay, if there is none, so that's all for today. Thanks a lot for joining and have a great weekend. Okay, so just write it down here. Okay, thank you guys. Thanks a lot for joining, and with this, we are done with today's session. Thank you. Okay, sorry. So yes, the law of intersection and union for the both the fuzzy sets A and B, they are dual in nature. Okay, so when you take the complement of union, okay, or you can also write it down here. So if you are taking the negation, so A union B, okay, that is equal to B intersection B, right? So you can also write it as this is 1 minus A union B, right? Okay, that is equal to A. This one you can write as 1 minus A intersection 1 minus B, right? S- Sorry, just a second. Okay, yeah, right. Is it clear till here? So now if I want A union B, that will become 1 minus A intersection 1 minus B, right? So this is called as complement of union. Uh, and similar to complement of union, we also have complement of intersection. So in place of union, you write intersection, negation, right? And you also find A union B. Sorry, A intersection B. So, okay, the complement of intersection. So basically, this is going to show that both are dual operation, which means that they are interchangeable under negation. Okay, do you want me to explain with an example or something like that? Or you understood? No, for example? Oh, okay, cool. Thanks. So I'll just erase this off so others won't get confused. You can take some random A and B values and you can try it yourself as well. Okay.